Hey, greetings everyone. Daniel Lowrie here with Antisyphon Training, and today I'm going to walk you through solving one of the Flash CTF challenges from December 2024 called Abashed Confessions. A lot of fun, deals a little bit with encryption. We get to play with Python, do a little bit of an analysis. It's going to be a good time, so strap on your helmets, kids, because it's time to jump in, shall we? Here I am logged into MetaCTF, as you should be too. That way you can follow along and play along with me. And here we have the problem, right? Let me scroll this down just a hair and see what's going on. That was a little too far, Daniel, but there it is. The Federal Bureau of Elf-Investigation. Funny stuff, right? Classic MetaCTF with their humor. Let's see what you did there. And you got me, a real rib tickler. It is kind of funny, actually. But they caught this suspicious letter in the mail. Can you decode it to make sure nothing nefarious is going on? That should be an interesting thing to do. Here's a photocopy of the letter. And as we scroll down, we see that we have what seems to be Wivzy Hermby give. That almost sounded like a cursing, but it's a little crazy. I mean, who wrote this thing? Was it Swedish Chef, right? Did Gary Busey go on a weird tirade and write it all down on the back of a cocktail napkin? It sure looks like it, but no. What this is, what we're looking at is obviously some form of encryption. Good news is, because this is beginner friendly, the encryption shouldn't be too difficult for us to figure out if we just do a little bit of what I like to call analysis. Say it with me, kids. Analysis, right? If we analyze some of the things, maybe we can pick out a thing or two that will lead us to give us the bits that we need to try to figure out how do we decode this? How do we unencrypt this message? Let's go back to it, shall we? Now, this is a little bit difficult to work with, so scroll all the way down on the bottom of this challenge. If you've logged into MetaCTF, just do a search for the Abashed Confessions challenge. It is also under the encryption-based challenges. And it says we have a transcript of the letter there, so download that. I've already done that hard work. My turkey is cooked, so I'm going to pull it out of the oven. I'm going to jump over to my text editor of choice, which is just whatever. I think it's Mousepad, which is what comes with Kali Linux. And here is the letter. Now I have nice text in which I can work. So you open it up in your text editor of choice, and let's start the analysis phase of what the heck is going on here. What can we do? What can we learn from this? All right. So I can see that this first line, this whivsy kind of thing going on. Okay. I can't really make out too much of that. I do see a comma here. I see things like periods at the end of long lines of text. I see, let's see if there's any other thing. Oh, there's an exclamation mark. You'll notice everything's kind of broken up into lines of text or blocks of lines of text. It's not one big block. It's not something to that effect. It's not spaced out or anything. It actually kind of looks like someone was writing it in a weird language. You know, some contrived language or something. So, okay, could this possibly just be English? It's a good possibility, right? Let's jump back in. So I see other characters. I'm looking at the characters as well. I see uppercase and lowercase and uppercase and lowercase. And we have special characters like the comma and the period. I see a single quote there. There's a parentheses. Anything else that looks interesting to us here? To me, this has all the telltale signs of it actually being a written letter. It's just you've obfuscated the English alphabet in some way, shape, or form, right? Especially if you look at like right here, it says K.H. Specifically, that is a capital K period, capital H period. I don't know about you, but when you write a letter and maybe you go, you know what, there's a little something extra I wanted to add that letter that wasn't really pertinent maybe to the body of it, or it was an afterthought. I've already written the letter. I was like, oh no, I forgot to say, what do? We do postscript, PS, which is typically formed as a capital P period S period, right? Kind of what we're seeing here. And then another thing that really caught my eye was this right here. Now, you can see that there's a capital letter, 3 lowercase letters, and then 3 capital letters, and then an open curly brace. Some underscore separated value text, and then a closed curly brace. does that seem like a familiar format? That is a common format for flags. Maybe it's flag, curly brace, something or other, but we're here on MetaCTF. MetaCTF, their flags are formulated as capital M, meta, capital C, capital T, capital F, open curly brace, close curly brace, and inside the curly braces is the text string, the flag string, whatever the case that is, whatever's going in there. So that looks a lot like that. From that, what can we deduce? What can we learn from all this analysis? I got upper and lowercase alphabet characters. I've got punctuation. It's most likely just the alphabet jumbled up in some way, shape, or form, right? And then I definitely have what looks like a flag in the body of this letter. So I'm learning about characters that are in here. Now my job is to reverse them. How do I turn them back into the thing that they once were before they were mutated by whatever encryption that was used? Well, first, I want to show you one more thing that I analyzed in this and I thought of. When you're thinking about encryption, one of the best things you can do is start thinking of things that repeat or known values. That kind of stuff can help you reverse encryption. Because it kind of shows you, well, if I know what this is supposed to be, I can figure out how it was encrypted, and therefore I might be able to figure out how I can unencrypt it. Okay? And hopefully that works with us here. Let's jump back in. One of the things that I noticed was like right here, got this Z character. And that is weird. There's just a Z all by itself. Now, in and of itself, that's not a big deal. But if you look through and you continue to see there's another single character, and it's almost always capitalized. If not always, but when it's by itself, it is capitalized. It's just sitting there. There's two words in the English language that only have one letter in them. That is the word a, like a boat, a house, or not a plane, that kind of thing. Then there's I. I went to the store. I called my mother. I did blankety blank, or did something, or bought something, or whatever the case is, right? Those are the only two single letter words in the English language. You don't suppose that I is R and Z is A, or A is or the other way around. Let's figure it out. Let's see if we can analyze this a little bit more and see what's going on. So there's an R. I do see this one. This is something that I thought, okay, here we go. We've got R, single quote, and then an N. Okay. So if it's A, that doesn't make sense because we typically don't see A apostrophe something. We see I apostrophe a few things like I'll, I've, I'm. Those are contraction words. Okay, could this be a contraction? So if by the power of deduction, the R is an I, that makes the Z an A. Z is an A. Long story short, you put all these characters down, you write out the alphabet, and you start putting characters that you find here that you pretty much know what they are, like this, right? If I'm assuming that this is all true, I can assume that the N, V, G, Z is meta. And since we just thought, hey, isn't Z an A and R an I? Guess what? The last character is a Z. That fits our narrative, right? That fits that this. And if the other says right here, if we go back to our right there, we see I apostrophe N, but it's an R and that's an I. Then N is M for I'm. This is most likely the contractional word I'm. If N is M, this is fun, right? Then this N would be a capital M, deobfuscated, decrypted. So now we've got M and A. This seems like it is meta, CTF, then the flag. Okay, so from there, what do we do? Well, we got a few options. We got to try to figure out what kind of cipher this is. At first, I thought this was like a rotational cipher, but it is a substitutionary cipher. But as I was doing my research, I found out it was something called an Abashed cipher. Very cool, right? Basically, what it does is it takes your alphabet and reverses it. A Z is an A is a Z. It's that simple. B is Y Y is B, C is X, and so on and so forth. So you just take your alphabet, A, B, C, D, E, F, G, all the way to Z, and then reverse it, Z, Y, X, W, V, U, T, S, and so on. Man, that's hard to do. I don't think that should be any part of any test because that's difficult to do just sitting around. But there you go. So that is what it is. It's an @bash cipher. Hold on. @bash, this is Abashed Confessions. MetaCTF. Oh, you crazy kooks, you clowns. I get where you're going with this. Hopefully you do as well. Okay, now that we know what it is, let's jump back into my PC here and let's solve the puzzle, shall we? Now, I'm just going to get the flag and let's see. I've written a Python script and it is called getFlag, if I'm not mistaken. So I will Python 3 get. It helps if you do it correctly. There you go. getFlag.py. And there it is. MetaCTF, both treats and messages stolen. This was fun. You're probably sitting there going, hey, yeah, cool. How'd you do that? What was the thing? Right? I figured that'd be worth us checking out and trying to see. So let's go back in. Let me show you how I did this. Here is just the strict Python code that I did here. You can see that I'm playing around with the alphabets. Here's our flag string. And then I do a bunch of meddling with it down here in the code block. Let's take a look at something a little more useful here where I've heavily commented this so we can see what's going on. First thing we do is we got to define our alphabet so that we can mess with it, we can play with it, we can do what we want. Here I've just made a variable called alphabet upper, and I've defined A through Z all uppercase. Then I need to reverse that. So that's what I do with my next step, reverse the alphabet. And I use this little trick right here called a Python slice. And this is a great way to just reverse something really easily. This is the format for a Python slice. You have your start, which is what's before the first colon, right? So start at the beginning of a sequence is the first colon. I can put a value there if I want, but if I just leave it blank, just a colon, it just starts at the very first character or thing in the sequence. Then you have the second colon, stop at the end of the sequence. Again, I could put a value there, which is not inclusive if you do put a value, but for what we're doing, we're just leaving it. I want to go from the start to the end, colon, bam, simple, easy. We like it. Then you have this -1 or -1 or however you want to put it. This is how we step backwards to the statement. This is the step. It's how I do. If I put a 1 there, it would step incrementally by 1 forward. If I put 2, you get the idea, so on and so forth. So then I just make a variable called alphabet upper reverse and make that equal alphabet upper. So grab this character set and then walk your way backwards through it with the slice. Easy, right? Nice little trick, really fun. I'm not saying it's the only way to get this done, but it was the quickest way I could figure out how to do it. Then I do the same thing with the lowercase letters, right? They're in the mix too. So I define alphabet lower. I give it A through Z, all lowercase. I do the same reversing that I did before, except this time with the lower. So I create the alphabet lower reverse variable to store that in. And I use slice to reverse the alphabet lower variable contents. Bada bing. Man, isn't this fun? Aren't you having a good time? I know I am. I know this is a good time for me. All right, now, next thing we do is we got to provide the encrypted flag, which is right here, fairly simple. A nice little double quotes around it. Give it to them, enjoy. Encrypted flag, that's the name of the variable. And then we create a variable for the actual flag itself to hold the decrypted value, which right now is just empty. Now, here's where the real fun begins. We're going to use an if-else block, conditional block here. I think I skipped a thing or two. Yeah, there we go. And a for loop to work on the information so we can get that flag decrypted. We start with a for loop, right? Because for loops are great for iterating through known ranges of things. So if I get a range of something, I feed it to the for loop, and the for loop will iterate through each item in the range until it comes to the end. And once it reaches the last thing, it stops. It ends itself. That's what we like. All right, so then we have this char, which is the loop variable, and you can see that here. So we start the for loop with 4. I throw it char for the char variable. Well, you can make it anything you want. You can make it blah if you feel like it. Doesn't have to be, I like to be a little descriptive so that I understand what the heck I did when I go back to it. It's always a good coding practice. So I say for char in, and then I give it this right here, which is the iterable. Right? This is the range. This is the thing that it's going to iterate through. Right now, it's that encrypted flag. It's that gobbledygook stuff right there, right? Okay. Down we go. So once we get the for loop cranking, now we're going to use some conditional logic, right? If else, or elif, else. And then that will help us decrypt each letter as we iterate through all the gobbledygook in the encrypted flag. Now, we do need to check a few things before we get too deep in the weeds to make sure that we're doing the right thing to the right character. So we're going to check and see if it's uppercase. So if the character is alpha, is it an alphabet character? And logical and throw in there. So both of these things must be true for this statement to render as true. Is it upper or is upper, right? So I've got char is upper. So this is just the basically the function or the method that's being applied to whatever's on that char variable. I want to check it. Is it an uppercase thing? If it is, cool, this is where I want you to go. Do this next. What's the next thing we're going to do? We're going to find something. I want you to find, which is a Python built-in, like I say here, basically greps for the first occurrence of a value. It says right here, I'm going to create this variable called index. Again, you can call it anything you like, but alphabet upper reverse dot find. Okay, what are we doing? I'm looking for the character that we're iterating for. Once I find it, I can then do that transposition. I can take the alphabet upper from the index, compare the two, tell me what it's supposed to be, and then add it to the flag. That's what this little plus minus thing does. It appends to an item. So if we got a variable called flag and there's nothing in it, it will append whatever it finds in that index that transposes to the right character into the flag. I know it seems easier when you're just sitting around cranking out code. When you got to explain it, it can get a little difficult. But once we get this out of our way, once we've figured this out, we're going to do it again for the lowercase stuff. And then we're going to mess around or maybe look at and figure out what to do with any characters that aren't alphabet characters, and then move on our merry way. We're almost done. So here we are, lowercase. We're doing the same thing. Elif character is alpha and char is lower, right? So another condition. So if it doesn't meet that condition, maybe it meets this condition. I got the index. I've got the alphabet lower reverse. I grab that and I say dot find this character. Does this character exist in this variable? If it does, cool. Throw it in the flag, append it to the flag. That's where you get this, the alphabet lower index, right? And it's just going to iterate. That's what that for loop's going to do. It's going to keep doing that. Now, if it's not a alphabet character, either upper or lower, what do we do with it? That's what the next piece is for. And else is a great way to do this. You can do this in a bunch of different ways, but this is just a very simplistic way of like explaining it to you. Else can tend to be a catch-all. And it's always good to have one, at least in my estimation, because you might not consider all the possible ways in which this might go. Else can kind of catch all those things that you didn't think about. But I did say that whatever else you find, so periods, exclamation points, curly braces, so on and so forth, parentheses, just add that to the flag. And then finally, print the flag out, call it a day. And if it all works, it should do what we got here and spit that right out. And there you go. That's how you solve this. Hopefully that made some sense to you and you're like, man, this is so fun. This is so cool. I want to do more. If you want to do more, definitely check out MetaCTF, get signed in, get logged in, and find those flash challenges. They put new ones out every month. It's going to be a lot of fun. There's write-ups for them as well. I'm going to continue to do more walkthroughs. So definitely, if you like what you saw here, like and subscribe to the Antisyphon Training YouTube channel. Check us out on all our socials. We got a lot going on. You want to stay in the know on what's going on. Plenty of free resources for you. We are here for you out there. We want you guys to learn and give back to the community so that you guys can do anything you want in your career in cybersecurity. A lot of fun stuff going on with us over at Antisyphon and MetaCTF. Whew. That said, kids, thanks for joining me. And until next time, have a great day.